The definition of the convolution is initially tricky because you're usually presented with this definition before building up why the operation was defined as it is. I always found confusing what they call time reversal and shifting. Usually what that means is you take the signal x and impulse response h, re-index it by the dummy variable k, and then afterward compute the sliding windows opposite to each other. But it really seems confusing to think about what that even does. So I'll create a small demo in MATLAB of what that means. So I'll show this here. On the top left, I have a signal x of n, which is a square wave. And on the top right is my impulse response I made up of a triangle wave. And what's going to happen if you try a multiplication of these two signals here on the middle left is the end of the wave is actually syncing up with the beginning of the square wave. You don't actually want this in a convolution operation. You actually want the beginning of the impulse response to align with the beginning of the input signal. For this reason, we reverse the impulse response and then perform the sliding window for the convolution. Actually, what they call on the middle left is actually called a cross correlation, which measures more the similarity between two signals. It really does a different effect. On the bottom, you can see the convolution output, which shows how a triangle wave acts on a square wave. That's all I would like to say here. If you read around reasons why we do the time reversal for the convolution, you might hear arguments saying that's just how the convolution is defined, or maybe you need it because it needs to be commutative or because of causality. But I hope this visual is one that helps give a better intuition of what's happening. And it's really about the alignment of the signals when you multiply them.